In this section, we'll understand a very important concept in statistics called confidence intervals. Before we go and understand multiple ways of computing confidence intervals, let's understand what confidence interval mean. Imagine if I have a random variable x, which represents the heights of people, right? And let's assume it comes from some distribution. And let's assume I don't know whether it's Gaussian or not, I don't know whether it's uniform. I don't know what distribution it comes from. Let's assume, okay? But let's assume I have 10 observations, x1, x2, x3, so on, so forth, x10. Okay, so these are random. This is basically a random sample from my random variable x of size 10. Okay, so this is basically a sample of size 10 because there are 10 observations here. Now imagine if my task is to compute, is to estimate actually. If I want to estimate the population mean, if I want to estimate the population mean of x, okay, which is represented by mu, how do I estimate this? Okay, one simple way that we know how to estimate it is basically I'll say mu is approximately equal to x bar, and x bar is nothing but 1 by n summation of I equals to 1 to n xi, right? This is basically simple average. This is basically your simple average, right? This is nothing but your simple average. Now, when I'm estimating the population mean of x, right? If I use this is sample mean, right? This is called the sample mean, okay? And this is my population mean. This is my population mean. So, if of course this is true, this is approximately equal to this. Now, while this is interesting, like I can estimate my population mean to be equal to my sample mean. There are a couple of hiccups with this. Okay, the first one is as my sample size increases, in this case, as n increases, right, my x bar will come closer and closer to mu, right? Let me read this. As n increases, my x bar will tend towards, will move towards my mu, will be closer and closer to mu, right? So somehow we have to use n here, isn't it? So of course this is an approximation. This is not an exact equal to. Remember, this is approximately equal to the sample mean. Your population mean is approximately equal to sample mean. If I just say that my estimate of mu is equal to x bar, this is called a point estimate. Such an estimate is called a point estimate. Such an estimate is called a point estimate. Here you're giving one value and saying, I think the best estimate of mu that I can make is nothing but my x bar. So again, just to quickly recap, this is the population mean, this is the population mean, and this is the sample mean. Okay. So while this is okay, it's not the best that we can do. There is actually a better way to estimate your population mean using probability and statistics. Let's see how to do it. Okay, let me actually take 10 values. Okay, I said I have values from x1, x2, so on, so forth, x10. Let me actually put some values here. Okay, let's assume my x1 is 180, my x2 is 162, my x3 is 158, my x4 is 172, my x5 is 168, and x6 is 150, 171, 183, 165, and 176. Okay, these are heights of people in centimeters. These are heights of people, heights of my people in centimeters. Okay, seems logical. I have 10 numbers here. Now if I used point estimate, okay, my point estimate of population mean is nothing but, it's a simple average of all of these values, right? It's nothing but 1 by 10 summation over I equals to 1 to 10 xi, and that is roughly equal to 168.5 centimeters. I did this computation earlier before I started this video lecture, so you can verify this, by the way. If there is any error, do let me know. I hope I've done the math clearly and concretely with no errors, hopefully. Okay, so this is called a point estimate. Instead of giving a point estimate, imagine if I give an alternative estimate, which is like this. Imagine if I can make a statement like this. If I can say that my population mean, right? My population mean lies in the interval of, let's say, 162.1 centimeters and 174.9 centimeters with 95% probability. With 95% with probability. Okay. See, this is a point estimate, right? Here I'm saying I think that the population mean equals to 165.5 centimeters. The other way of saying this is, what I'm saying here is that my population mean lies in this interval. It could lie anywhere between 162.1 centimeters and 174.9 centimeters with a 95% chance. Okay, so while this is a point estimate, because you're giving one single point or one single value and you're saying that my population mean equals to this, in this case I'm giving a confidence interval. Okay, I'm giving an interval, I'm giving a value, I'm giving an interval. I'm saying this could lie anywhere in this range and I'm giving a confidence to this. And I'm saying that I think I'm 95% confident that my population mean will lie in this interval. When you make statements like this is called a confidence interval. Okay, so when I make statements like this is the whole idea of confidence intervals. I'll write CI for short, for confidence intervals. Okay, so this is the idea of a idea, and this is much richer. Instead of giving a point estimate, if I can make statements like this, that my population mean will lie in this interval between 162.1 centimeters and 174.9 centimeters with a 95% chance or probability. Here I'm giving a 95% confidence, which is important. Here I'm giving a 95% confidence, and I'm giving an interval here where I'm saying this will lie somewhere in this range, greater than this, greater than equal to this, and less than equal to this. Okay, this is much more richer. This is a much more richer in terms of information. This statement is much more meaningful than just making a point estimate. So this is the whole idea of confidence intervals, and the name confidence interval comes because I'm giving an interval and I'm also giving a confidence of what is the probability that my actual variable that I'm estimating here, or the statistic that I'm estimating, which is the mean here, on what is the interval that it will lie in. That's the whole idea of confidence intervals, right? As you can quickly notice that this statement is much richer in information than a simple point estimate. We'll see how to compute this in the next videos.